Beta distribution is extensively used in project management. Beta distribution is basically used to represent uncertainty involved in completion times in project management. It is very similar to triangular distribution. It has parameters A, which is minimum, C is your mode, and B is your maximum. In addition, we have alpha and beta also, and they are both positive. Um, so it might be noted that beta distribution is not in closed form, so we already have a built-in uh, function to get the inverse CDF, and we will be using the formula BETAINV, and then we will have probability comma alpha comma beta comma A and B, where A and B are lower, small a, lower limit, small b, upper limit, alpha and beta are positive. And here this p is basically my rand function. So if my small a is equal to 0 and if my capital B is equal to 1, then my beta distribution is called standard beta distribution, and we have tables available for standard beta distribution. So you have to like transform beta distribution into standard beta distribution if you want to use tables. Okay, so here you can see different combinations of alpha and beta are giving you different density curves. So if alpha and beta both are zero point 0.5, you will get a U-shape distribution. And if you are changing values of alpha and beta, you will get different shapes. This means that beta distribution is very versatile. Here, this is the spreadsheet simulation which we can use Excel to generate samples from a beta distribution. So for alpha as 0.5 and beta as 0.5, here rand command I will be using, and x is basically a built-in function, beta in v. Here a5 is basically my rand value, comma alpha and beta. And here if I want to provide values of upper bound and lower bound, I can always um, provide. If not, then my samples will be between 0 and 1. So I will be getting values, or I will be getting random variable following a standard beta distribution. So let's say right now it's 0.996, so we can say okay, it is a random variable which is following a standard beta distribution, and with each if I'm changing values, it will be um, changing, because if I'm changing rand value, it will affect my x. But let's say if I want to change value of a and b, let's say 5 and 100. So here you can see now it is giving me a random variable between 5 and 100, and it's 89. So if you are not providing values of small a and small b, which we did here, 5 and 100, then it will give you random variables is between 0 and 1. So once I have this here various random numbers, let's say I want to do 1000 iterations, and for 1000 iterations, or let's say 10,000 iterations, and if I draw a histogram of this x, right, then the histogram should be a U shape. And this is also, I would say, a small assignment for students to set up this sheet and then draw a histogram. Also, I recommend students to change the value of alpha to 2 and beta to 2, and then draw a histogram. In addition, do it for alpha as 2 and beta is equal to 0.5, and then check that whether you are getting uh, the same beta density curves or not. If you are not getting it, then I think you are making some error. So that's for small task. For histograms, I recommend using Minitab software. So because beta distribution is not in closed form, and in addition, the parameters of beta distribution, I'm talking about alpha and beta, are not easily estimated, right? So it's sometimes difficult to use beta distribution in project management. So that is why we can use triangular distribution in project management. We can use it when data is limited, so that's why triangular distribution is also called lack of knowledge. And here is the reference which I am providing, that we can use triangular distribution in place of beta distribution in risk analysis and in project management. So a random variable with a triangular distribution is used when it is assumed that the likelihood of value first increases linearly to some maximum value, which is called mode, and then it is decreasing linearly till we hit the upper bound. So I have lower bound, I have upper bound, and m is my most likely. So I have like two portions of triangular distribution, and here is z is a random variable here. A is my minimum, and m is my most likely, and b is my upper bound. So here, if y, which is a rand function, if it is less than m minus a divided by b minus a, so then it will be using this formula. And if this y, random number generated by Excel, is basically greater than m minus 1 divided by b minus a, then we will use this second formula, and this is the inverse CDF formula which we will be using in Excel. Again, we have 0 and 1 here because the rand function value cannot be less than 0 and the rand function value cannot be greater than 0, so that's why we have 0 and 1. So I have lower bound as 1, and I have my most likely value, and I have my upper bound. So first it is important to calculate this value c minus a divided by b minus a. This is my threshold value. So if my rand function is less than, rand function means this value, this is less than 0.6, right? So then I will be using this upper portion of the formula. And if this rand function is, let's say, greater than m minus 1 divided by b minus 1, and here they are changing notation, c minus a divided by b, then I will be using the lower portion of this equation. And for such scenario, I can always deploy if command in Excel. And if command is basically telling me that okay, if particular condition is satisfied, then display or follow one formula. If it is not satisfied, then go to another formula. So first step would be to generate rand with the help of rand function, generate random variables, and then use this formula here. So if this number a8, which is my rand function value, if it is less than this threshold value, so then use this formula, right? If not, then go to the second formula. So this is basically how we are using we are sampling from a triangular disk. So how this works, let's say passing score in a test is, let's say, 40, and I want to generate random numbers between 0 to 100, right? And I'm saying that my to pass a test for a student is, let's say, 40, right? So what I can do here is equal to if, right, if this score is greater than 40, then I can say the student passed. If not, then failed. So this is how, because the score is 7 and less than 40, so we have this failed. So let's say okay, 49, which is greater than 40, so the student number 2 pass this test and keep on. So they are basically using the logic of if condition in the Excel sheet for sampling from triangular. In addition to that, if you can see the PDF, so PDF of triangular distribution is very similar to that of beta distribution, and we are using CDF curve to draw samples, and if you can see, both curves are almost identical. So we can safely say that in project management, risk analysis, or different other fields, if we cannot estimate parameters of beta distribution such as alpha and beta, we can always use triangular distribution instead of beta distribution. It might be noted that triangular distribution belongs to the TSP family, which is called two-sided power square distribution, and it has a variety of shapes. So the density curves have variety of shapes. However, discussion of TSP distribution is beyond scope of this course, so we will just stick to triangular distribution. And that is the end of today's lecture.